Hello dear students, welcome back grade 12. We are going to complete our lesson correlation coefficient. Today it's part 2. Part 2, second type of correlation coefficient, it's Spearman's rank. Spearman's rank. Let's start. The Spearman's rank correlation coefficient, we are going to use that notation. R and down to it S. R and down to it S. S from Spearman, R from correlation coefficient. As a person. A person, we used just the R, only a letter R. But Spearman's correlation coefficient, we are going R and down to it letter S. This is the notation. We don't need to write Spearman's rank correlation coefficient every time. But just I see RS, it means Spearman's correlation coefficient. And the formula which we are going to use, it's RS equal 1 minus 6 multiply sum d square over n power 3 minus n. So means RS or Spearman's rank correlation coefficient, just 1 minus this bit. Bit d, we need d square, d from difference. N power 3 minus n, and I said before n means a number of values. Example. Calculate the Spearman's rank correlation coefficient and comment on the result. Here we have an example. First column, it's height of sunflower in centimeter, and second values, it's width of the stem in millimeters. I'm going to arrange the first values in the first column, ascending or descending, as you like. Same, just give each value here a rank. In that example, I'm going to give them the rank accordingly greatest value. I'm going to start with the greatest value and then give it number 1. So 256 is the greatest height. Its rank is going to be first. 256 is the first, 234 second rank, and 190 third rank, 183 fourth, 134 the fifth, 112 is the sixth, and last value or the smallest height or shortest, 89 is its rank is 7th. Here, according to the width of stem in millimeters, I have different values, and greatest value is 32 has rank first, 29 is second, 24 is third, 21 is fourth, 20 is fifth, 18 the sixth rank, 14 is the seventh. D here, it means difference. So, and next column is d square. It means power 2 to each value. Let's count how many columns we have in that table. 1, 2, 3, 4, 5, 6 columns. First, X, and second rank of X. Third, value of Y, and the rank of values of Y. And then the difference between each two corresponding values. Like 4 and 4, difference is 0. 5 and 7, it's 2. 2 and 3, and so on. Let's see. Here we have 4 minus 4, 4 minus 4, 0. 5 minus 7, negative 2. 2 minus 3, negative 1. 1 minus 1, 0. 3 minus 2, 1. 7 minus 6, 1. 6 minus 5, it's 1. And then d square. D square means power 2 to each value. 0 square, or multiply the value by each side. Negative 2 times the negative 2, 4. Negative 1 times the negative 1, positive 1. 0 times 0, 0. 1 times 1, 1. 1 times 1, 1. 1 times 1, 1. And you have to calculate the sum of D square of last column. The sum of D squared is 8. And you have to know how many pieces of data you have. Let's count. 1, 2, 3, 4, 5, 6, 7. And the rank, the end with 7. So n means the value of n is 7. Using the formula, which is RS equal 1 minus 6, multiply sum D square over n power 3 minus n. L6 is a constant, and sum D square, we calculated 8. n power 3, it means 7 times 7 times 7 minus Ln, which is 7. Just plug 6 times D square, yani 6 times 8 equal 48, and the n power 3 minus n, yani 7 times 7 times 7 minus 7, it's 336. Using your calculator, you will get 0.857. It means, since the value of RS is positive, it means it's a direct, and since it is greater than 0.6, it's strong. Okay? So it means in RS, or Spearman correlation coefficient close to 1, we can conclude that the wide the stem to higher the sunflower growth. Another example. Calculate the rank correlation coefficient of Spearman. We have 1, 2, 3, 4, 5, 6 values x, 6 values lil y in a simple table. So I'm going to calculate the rank correlation coefficient. We need another table to ascending the. Now I'm going to give the order in ascending order. Okay, we have the values 4, 6, 7, 7, 8, 10. 4 smallest, I will give her first rank, 6 is the second, 7 is third, and 7. How come? 7 and 7. Why? It's not fair to say that 7 is the third and that 7 is the fourth. It's not fair. So I'm going to calculate the average. What is the average between 3 and 4? The average, just add the two values, divide by 2, it's going to be 3.5. And 8 is the fifth, 10 is has rank 6. Step 2, the ascending order of y. The smallest value here is 5, next 7, 8, 9, 9, 10. I have 2 repeated 9. So, since the 5 is the first, 7 is second, 8 third, the 2 9s, I'm going to give them 4 and 5, and then the average between them, just 4 plus 5 divided 2 is 4.5. I will give each 9 the rank 4.5. At the end, the value 10 has a rank 6. The table, 1, 2, 3, 4, 5, 6 columns. First, x, second, y, rank of x, I calculated, rank of y, and the difference between each two ranks. 6 minus 1, 5, 3.5 minus 3, 0.5, 5 minus 2, 3, 3.5 minus 4.5, negative 1, 2 minus 4.5, negative 2.5, 1 minus 6, negative 5. And then multiply each number by itself. 5 times 5, 0.5 times 0.5, 3 times 3, negative 1 times the negative 1, negative 2.5 times the negative 2.5, negative 5, and multiply by negative 5, and then find their sum. After that, just plug what I calculate in that formula, which is 1 minus just this bit, 6 sum d square, which is 60.5 over n power 3 minus n. Don't forget, n means how many values you have, how many pieces I have here. Sum d square is 66.5 and the number of values is 6 power 3 minus 6, just 1 minus that fraction in your calculator, 1.9, it's negative 0.9. Negative means the correlation is inverse. 0.9 means it's strong. Please note that there are two different correlation analyses. We studied till now two correlation analysis. Spearman correlation, and that type of analysis is often used to evaluate relationships involving ordinal or ranks variables. For example, you might use the Spearman correlation to evaluate whether the order in which employees complete a test exercise is related to the number of months they have been employed. But Pearson correlation evaluates the linear relationship. A linear means increase together, decrease together, or same direction or opposite direction, direct or inverse. Pearson correlation evaluates the linear relationship between two continuous variables is associated with a proportional change in the two variables. For example, you might use the Pearson correlation to evaluate whether increase in temperature at your production facility are associated with decreasing thickness of your chocolate coating. You have to note that also Pearson's correlation coefficient is more accurate than Spearman's correlation coefficient because it deals with the real values, not with the ranks of these values. Thank you, grade 12. I hope to understand and do your assignment, please. I will send it on LMS. Thank you.